Hi, I did not like how this slide went down during class, and I wanted a chance to explain it better. What I had done is, unfortunately, I didn't match my picture with what I had for the description of the two redox reactions. I have no idea how that happened, but anyway, that got me very mixed up, and I apologize. So I want to describe this in better detail. So what do we have here? I'm going to add a pen, hopefully. It only sort of works when I'm in record mode. So what do we have? We have a zinc metal here, and that is right here. And what do we have also? Zinc ions that have a positive charge. So as the electrons flow into the wire, then the zinc metal that is whole will have no longer a neutral charge. It'll have two more protons than the electrons in each of those atoms. So each of those atoms will fall off your zinc plate and become zinc ions floating around in solution. So then the electrons flow along the wire over to the cathode. And on the cathode, we have copper as a solid plate. And what happens here is the electrons come along. There we go. I'm not sure how I get that little thing that comes up. And what the electrons do is they will match up with the copper ion that's floating around in the solution. And as they combine, they will turn into copper solid. So when it's an ion, it's floating around in solution. When it is not an ion and neutral, it becomes part of the metal plate. So we have this electron flow that goes from one side to the other, and it's changing the size of the electrodes. So on one side, you actually lose some of the metal as the metal's falling into the solution as an ion. On the other side, you actually gain metal. So that plate will get larger over time as the copper ions join with the electrons and form onto the plate. Now, in order to balance this out and have a continuous flow of electrons as such, it's in an ion-based format in the salt bridge. This is a salt bridge right here. And what do we have? We have some ions that are on both sides. So on this side, nitrate, which is negative, will fall into solution and balance out those positive ions. And on the other side, you have some nitrate in there. So it would have been originally copper nitrate, and it falls into ions of positive copper and negative nitrate. And in order to balance it off, as the copper gets deposited onto the copper solid plate, then the potassium comes along and matches up with the nitrate. And that ends up being a balance of the ions, of positive and negative ions inside the solution on one side. And on the other side, you have a balance of the ions of Zn2 positive, zinc positive, and nitrate negative. So that's what's going on. And you have this continuous flow until you use up all the zinc, because at some point you're not going to have a full zinc plate anymore. So what are the reactions for this? Well, we have these half reactions. And on one side, we have the anode. And what we look at is a loss of electrons. Leo, loss of electrons. So you start with zinc solid. As the electrons flow out of the zinc, you end up with Zn2, zinc 2 positive, and 2 electrons flowing off into the wire. On the other side, we have a cathode, and this is where it's gaining electrons, and that is reduction. So what do we have here? We have a copper plate, and we have the copper ions in solution that match up with the electrons, and you form more and more copper solid. So when you combine these, you end up with the full reaction. So the full reaction, you've got electrons on both sides that cancel out, and you have copper ion and zinc solid. And then on the other side, copper solid and zinc ion. And when it's an ion, it's in AQ. That means aqueous solution, meaning it's inside water. That's all it means. So I hope this gives a better description of what went on this slide. I got it mixed up because I had the wrong things on there. So anyway, I hope this is more clear, and I hope to see you in class next time. Take care. Bye.